We'll illustrate the rest of this lecture with this example drawn from the AI literature. It's called the Wumpus word, invented by Gregory Yob in 1975. So the Wumpus word is actually a cave of 4 by 4 rooms. So we have 16 rooms that are interconnected, and we have an agent that evolves in this environment. And the idea is that these rooms actually have some danger, and this danger can be either a beast called the Wumpus that would eat anybody who gets into the room. It also have what we call pits, and these pits actually are bottomless, and whoever falls in the pit will be stuck there forever. These are examples of pits and the Wumpus. So we have an agent that starts at the room 1-1, and the mission of the agent is to navigate in this environment or the cave without being eaten or without falling in the pit. There is some reward. It's possible for the agent to discover some gold and get it and get out of the cave. So there are some other components, which is that help the agent navigate in the cave. If the agent is in a room that actually is close to a beast room or Wumpus room, this room will be smelly, so it has some stench. If the agent moves to a room in which there is some breeze, it means that there is some next room that has some pits, so the pits emit some breeze. So there are some percept that can help the agent navigate without being eaten or fall into the pits. So let's start formalizing the problem of the Wumpus word. So we have a 4 by 4 grid of rooms in the cave. Squares are called adjacent if they are on the same column or the same line. So anything that's on the diagonal are not. So for example, these two are adjacent and these two are adjacent, right? But these two are not. Okay, so squares that are adjacent to a Wumpus have some stench, smell. So we have a stench here, here, and here because these cells are close to a Wumpus. Cells that are, or rooms that are close to a pit, such as these three rooms here, have some breeze. This is what the pit emits. And also there is some glitter if there is, if only if there is gold in the room. So shooting the Wumpus with the only available arrow will kill the Wumpus, in which case it will emit a very big scream that can be heard anywhere in the cave. Also, grabbing picks the gold in the same room, and releasing drops the gold in the same room. All right, so this is the Wumpus word. So let's now define the Wumpus word in terms of the peace environment criteria. So remember, peace stands for performance, environment, actions, and sensors. For the performance measure, we're going to add 1,000 points if the agent gets the gold. We're going to subtract 1,000 points if it is eaten or fell in a pit. We are going to subtract 1 point whenever the agent makes an action, and minus 10 if the agent uses the arrow. The game ends either when the agent dies or comes out with the gold. The environment is a 4 by 4 grid of rooms. The agent starts in the bottom left room. That's the room 1-1, facing to the right. Locations of the gold and the Wumpus are chosen randomly with a uniform distribution from all squares except the first start square 1-1. Each square other than the start can be a pit with some probability, which is actually a probability of 0.2. So the actuators are left turn, right turn, forward, grab, release, and shoot. And the sensor will be stench if there is a Wumpus in one of the adjacent rooms, a breeze if there is a pit, a glitter if there is gold in the room, a bump if the agent is facing a wall and trying to go forward, and a scream is if the Wumpus is killed. This can be represented as a 5-element list in which we have an indicator for each of these sensors. So for example, stench, breeze, non expresses the fact that there is in the adjacent room a Wumpus and a pit. So we have to figure out which rooms have actually these two elements. The Wumpus word properties are as follows. It's partially observable because the agent can only perceive its closed environment, like the adjacent rooms. It's static because the Wumpus and the pits are not moving. It's discrete. We know exactly the actions and the outcomes. It's single agent. It's deterministic. And finally, it's sequential. Now let's use some informal language using symbols in the grid and do some logical reasoning about how the agent should evolve in the cave. So initially, the agent is in, these are the first steps. The agent is in the first room. And we know that by default, this room is safe for the agent. So the room, we're going to add the symbol OK to say that the room is OK to be in. So this room is safe. We're going to use the symbols A for agent, B for breeze, G for glitter or gold, OK if the square or the room is safe, P for pit, S for stench, V for the room has been visited, and W for Wumpus. All right. So initially, this room is safe, means that there is nothing in there. But also, by looking into this room, it says that there is no breeze or no Wumpus around. So we could either move to the room 1-2 or to the room 2-1. So suppose we pick to go to the room 2-1, then the agent will move in this room here. This room is visited, right? But this room has actually a breeze, which means that there is potentially a pit here or here. So I'm going to add a question mark to the symbol P to say that, is this a pit? Okay. So here the agent will think and not make any hazardous action, so it needs to really be careful. So what will happen is that the agent will need to go back to where it came from and explore maybe the room 1-2 before moving forward to any of these rooms, given that there is a risk it falls in a pit. So what I just did is an inference or a complex process in which I figured out things, which room to go to, where's the gold, where's the Wumpus, where's the pit, based on different time points, different locations, and all the percept that the agent has perceived. So this is this kind of complexity that we want to be able to embed in the logical agents using this kind of some sort of representation to navigate into its environment. So in the rest of this lecture, we'll study how to build logical agents such as the Wumpus that can represent information and draw conclusions to make the agent progress in its environment.